Hey, welcome back. We're going to continue our discussion with quotient rule today. So we start off with an easy problem. We want to find out where this function has a horizontal tangent. Well, we know that. That is just where the slope is just, of course, 0. And I can look at the graph and I can know what's going to happen down here at the origin. So I can kind of so I can kind of see where that's occurring here. But let's talk about it calculus. When we take the derivative, remember, for a horizontal tangent, anytime we see the word tangent, we're going to take a derivative. So when I take my derivative, I will be using my quotient rule. My quotient rule, low, d high times 2x minus high, d low. And of course the derivative of the bottom is also 2x as well. All over the bottom function squared. I'm going to clean this up a little bit. On top here, I'm going to get 2x to the fourth plus 2x. So that's going to give me 2x to the fourth plus 2x minus 2x to the fourth over, that's a 4, over x squared plus 1 squared. So there's my first step. Well, my second step now is just take our derivative and set that equal to 0. Something really kind of cool is going to happen here. The 2x to the fourth cancel, and I'm left with 2x over this x squared plus 1 squared equal to 0. When I cross multiply, this is just going to go away. So I just get 2x equals 0. So I get x equals, of course, 0. Now we're not done. We do have to find what they call the points, and that's our x comma y. Well, we have x, now we got to find y. Like, why is she my x? Finding y, let x be 0. So we're going to find f of 0. Remember, we're going to use the OG, the function itself. Plugging in 0, we get 0 over 0 plus 1, which is 0. So again, we do get the origin, which verifies what it looks like at our graph where the slope is 0. Very easy to do. All right, so trig rules. All right, these are the big ones. Okay, these are all of our trig ones. We already know that the derivative of sine of x is cosine of x. And we know that the derivative of cosine is negative sine of x. These are some extra ones. We saw these in our video yesterday. We did prove tangent is secant squared. We didn't prove cosecant. I'm just going to say we're just going to memorize it. So the derivative of cotangent is negative cosecant squared. The derivative of secant is secant x times cosecant of x. Oh, that's embarrassing. Let's scratch that out. That should be tangent of x. Oh, that's embarrassing right there. That should be tangent of x. And then the derivative of cosecant of x, man, that's also an error. That should be negative cosecant of x, cotangent of x. I am so sorry about that. So anyways, you want to make sure you get those fixed so we can make sure we know them for the test or quiz. I will get that fixed on my notes. Maybe not on this video here. Oops. So we just want to find the following derivatives. To get the derivative of secant, well, I'm literally just going to look up over here. It's just secant tangent. So it's just secant x, tangent x. And now I want to find the derivative of 2x, which is just plus 2. Very easy to do. So let's apply some properties to this now. Other derivative rules. Number 2. Take a look here. I'm taking this 5x times the secant of x. This is my product rule. Tangent of x is by itself. That's just my normal derivative. So I'm going to deal with my product rule here first. When we take our derivative, it's just our first function, 5x, times the derivative of secant. Well, that's just secant x, tangent of x. Plus, now be careful, the second, which is secant of x, times the derivative of the first, which is 5. So we got our product rule. Remember, the first times the derivative of the second plus the second times the derivative of the first. We're still not done. We still got to worry about that tangent of x. And my rule for tangent is just secant squared of x. Right there. And there is our rule. And there is our, of course, our derivative. Very easy to do. All right, let's take a look at number 3. This is kind of a fun one right here. Again, I'm going to use product rule time because I might realize there's an easier way to do this. If I take the derivative, my first function, secant of x, times the derivative of cosine, which is negative sine of x, plus the second, which is cosine of x, times the derivative of secant of x, which is secant x tangent of x. Tangent of x. Now, this may not look very nice, and honestly, there's our derivative, but this cleans up very nicely. And let's talk about why that is. F of x, secant is just 1 over. What's the derivative of 1? 0. So all of that's just going to become 0 if you were to simplify it. Boring, I know. All right, number 4. All right, let's take a look. There's our cosecant. When we take our derivative of cosecant, be careful with that one. Remember, I messed that up here, okay? We're going to get the following. Remember, now we're using our quotient rule. Low, what we did yesterday, remember that's going to be low d high minus high d low all over low squared. So my low is x squared. My derivative of the top, negative cosecant of x, tangent of x, minus high d low cosecant of x times 2x, all over the bottom squared. That becomes x to the 4th. Please don't write it as x squared squared. We like it x to the 4th. There's no derivative. Pretty easy to do. Don't simplify. Leave it alone. Of course, you can factor out an x if you like. All right, let's apply it. Let's have some fun now. All right. Evaluate the following derivative at the given value of c. So, all right, we've done this before many a times. C is just some random x value that they're going to pick for us. So this is our quotient rule. So when we do our quotient rule, remember it's going to be the bottom one, low, d high, 3x squared plus 3 minus high plus 2 d low, which is 2x, all over the bottom squared, x squared plus minus 1 squared. And now we have to plug in our 2 here. When you plug in 2, do this in your head. This is 4 minus 1, which is 3, times, this one might be a little bit harder, 4 times 3 is 12, 12 plus 3, 15, minus, 2 cubed, that's me, I'm just way 2 cubed, plus 6 plus 2 times, and that just becomes a 4, and the bottom becomes 4 minus 1, so 3 squared. Ooh, okay. So what do we get? 45 minus 16 times 4, 64 over 9. Yeah, we can leave it like that. I would just, I guess if you want to, what's that going to be? Nah. I'm going to cheat. I'll be honest. I'm going to cheat. I'm going to get my calculator. 45 minus 64. And they get negative 19 over 9. Easy peasy. Look at that. Did that in my head. All right. Let's take a look at number 6. Oh, man. This one's going to get tricky. So, again, we're going to use our quotient rule. So, we're going to do our quotient rule here. So, we got low, the derivative. Low. That's negative secant squared of x. Right there. Because the minus sign right there. That minus makes that a negative. All over the bottom function squared. 1 minus tangent of x squared. And now we're going to plug in the pi over 6. So let's see about this. We're going to need the tangent of pi over 6. Tangent of pi over 6. Let me see here. Pi over 6. Flip it. Oh, man. Okay, that's 1 over square root of 3. 1 over root 3. We'll need the secant of pi over 6. Okay, that's cosine, right? Well, cosine of pi over 6 is root 3 over 2. So this is root 3 times square that, we're going to get 4/3 minus 1 plus the tangent, again, is 1 over root 3 times a negative, and again, I'm going to square that, 4/3 right here. So that's a negative right there. Okay? So all over 1 minus 1 over root 3 squared. Oh man, this looks awful. So let's see. There's a quick way, and then there's like kind of a dirty way to do this. So let's see how we want to do this one right here. On the top, if I simplify this 1 over minus 1 root 3, man, we're going to get really good at algebra today. So if I were to simplify this one becomes a square root of 3 minus 1 over root 3 times 4 over 3. Minus, this now becomes root 3 plus 1 over root 3 times a negative 4/3. And on the bottom, I'm going to get root 3 again minus 1 over root 3 squared. And at this point, you kind of question, why am I here? So our LCD is the following, root 3 times 3. On the top, it turns out very, very pretty. Okay? These are just going to cancel. I'm left with the square root of 3 minus 1 times 4 minus, over here, same thing, they're going to cancel out. I get the square root of 3 plus 1 times negative 4 now. On the bottom, I'm going to clean up the bottom here a little bit. If I square this on the bottom, I'm actually going to get the following, the square root of 3 minus 1 squared on top over 3. And here, this 3, if I multiply by 3 root 3, right, the 3 will cancel, but I'm still left with the square root of 3. So I get the square root of 3 times, and wow, that's our answer. Uglier than that one. Good luck. All right. So if you like this video, go into the next few problems. We can take a look at some more. Okay, I'll see you then. Actually, you know what? We might have time. Let's go and do our tangent line here. We only got really one more example. Write the tangent line for the function in question 7 at root 3 pi over 4. Oh, we didn't do number 7. That's the problem. There it is, number 7 there. All right. So let's take a look at number 7 here. So we're going to take this derivative, f prime of x. This is our product rule. The first function, cotangent of x, times the derivative cosecant squared of x. Alright, so again, this looks pretty nasty, but we're going to plug this in. We want to find the values at 3 pi over 4. So cotangent is pretty easy. Pi over 4, cotangent is either 1 or negative 1. Cotangent is like tangent. It's the inverse of tangent. So at 3 pi over 4, tangent is negative, so this is just a negative 1. All right, the secant, to get the cosecant, let's do this. The cosecant of 3 pi over 4 is the flip of the sine of 3 pi over 4, which is 3 pi over 4 is root 2 over 2. Remember, this is just the square root of 2 over 2. In the second quadrant, sine is positive, so we flip it. We're just going to get 2 over root 2. That's what we get here. 2 over root 2 times the cotangent, again, is just, again, negative 1, plus, again, 2 over root 2. And again, this, and if I square it, I'm going to get 2 over 2, which is just, whoops, sorry, if I square that, that's not that. There we go. Sorry about that. If I square this, I get 4 over 2, which is just 2 right there. So if I simplify this, I'm going to get 2 over root 2 plus 4 over root 2, which is just 6 over root 2 right there. Yeah, that's just nasty. Who gave us that problem? All right. Now for part 8, we want to write the tangent line of the function at this point right here. All right, so we got to get a point. Oh, man. To get the point, we need to find the value at 3 pi over 4, which is the cotangent. Whoops, not cosine. The cotangent of 3 pi over 4 times the cosecant of 3 pi over 4. Well, we already know that this is just negative 1 times, and we know that this is 2 over root 2, so we get negative 2 over root 2. So our point, 3 pi over 4, negative 2 over root 2. Next, we need our slope, which we already have, 6 over root 2. So our tangent line, y plus 2 over root 2, 6 over root 2, and we get x minus 3 pi over 4. Wow. I would ask if you enjoyed that one, but I know the answer to that one already. That's about as ugly as they get right there. So make sure you definitely take a look at those. I will see you guys tomorrow. Have fun. Bye.